everyone. Welcome to the most exciting session. We kept the best for last thing today. Of course, I am biased, but my name is Anusha Ansari. I'm CEO of XPRIZE Foundation, and I've had the pleasure of serving as the co-chair of the GESDA Quantum Task Force for the past 18 months, and you get to hear about some of the work we've done. But before we get started, I would like to set the stage for the conversation we will have over the next hour and a half by inviting Fabiola Giannati to help us get into the mood of the conversation. Fabiola, of course, is a board member of GESDA and also Director General of CERN. Fabiola.
Thank you very much, Anusha. Does this work? Yes, good afternoon, everyone. So we are here today to talk about quantum. Sometimes people are a little bit nervous when they hear about quantum because it's something a bit mysterious. People think it's just for a few scientists to talk about it, but actually quantum is going to have a huge impact on our life. So we know that quantum technologies are among the technologies that have the potential to really have the most transformative impact on society. And this is not new. It was already the time of Richard Feynman, the great Richard Feynman, who understood that actually quantum computing had the potential to be much more performing than a classical computer, but the time was not ripe. But the time is ripe now. Over the past years, we have seen a huge increase in the interest in the work, in the research work made on quantum, huge investment, talking about billions and billions by both the private and the public sector. And I think it's realistic to think that in 10, 15 years from now, we will have a quantum computer which will allow us to solve problems that are intractable with the classical computers. So this is an important thing to mention. And the full potential of quantum is not completely known today, but we know that it will help, for instance, for health, for vaccines, for fertilizer, many other fields. And we'll have to work more and more to understand how we can really deploy this technology. Maybe I would like to mention that, of course, fundamental research is very close to my heart. I work at CERN, and CERN is a place where we see quantum mechanics at play every day because we work with the elementary particles which follow the rules of quantum mechanics. And maybe mention that when quantum mechanics was developed about a century ago, it was thought to be useless knowledge because it was completely far away from our world, our dimension, and our needs, etc. And yet we know without quantum mechanics, we will not have all the electronics gadgets that we use today, and we will not be here discussing quantum computing. So this is the first point. The second point I would like to make is that, however, with quantum, as with all other technologies, there is a danger. And the danger is that the technology itself will contribute to increasing the gap between developed and developing countries and those with and those without access to the technology. We know that nowadays the development of technology is not sustainable because it's contributing to a two-speed world. And that cannot continue like that. So it's important that we take this new technology now early enough, and we tried really to frame it in a way that goes to the benefit of all of humanity. And hence the idea of GESDA, of using quantum as one of our first solutions. There are two at the moment, for two reasons. First of all, because there is a lot going on in quantum, and so GESDA has the role of anticipating, and of course it's very important to start now to anticipating the potential of quantum, but also because GESDA is extremely well placed to make sure that quantum will be used in the best possible way. What does this mean in practice? Well, we'll have an Open Quantum Institute, which will be discussed during the panel. This Open Quantum Institute is going to be established with a process that we can discuss later on. But the goal, it has two main goals. Goal number one, open access to quantum technologies, because one of the reasons why there is a gap in today's society is that some large portion of the world population does not have access to technology, science, and education. And we have to stop this trend. We have to make sure that technology, science, education are available for free to everyone. So this is the first thing. By the way, open science, open technology also boosts science itself, because if scientists share ideas and technologies and accomplishment, of course, science gets boosted. The other thing is to make sure that quantum is used in particular to help solving and addressing at least the challenges that humanity is facing, from climate change to health, etc. And so the Open Quantum Institute will be a place where the quantum people that want to use quantum technology to help address those problems will have the possibility of doing so, regardless of their country of origin, their salary, their passport, etc. I think that one of the reasons why CERN is very much involved in this, and this I would like to share some personal thoughts related to what we do at CERN, is that because, well, first of all, we have competencies in quantum. As I said before, we work with the quantum world at any moment in time, but also because open science is pretty much enshrined in our convention. It's part of our DNA. What we do at CERN is for everybody and for free. This was the case with the web, which was made available to everyone to use and develop with free of charge. But also because we are used to work across fields, across sectors, public, private, and across national borders. And so collaboration, peaceful collaboration, is of course extremely needed, even in particular nowadays in an epoch of geopolitical conflicts. And so CERN thinks that the Open Quantum Institute will be really an excellent initiative that will allow humanity, will help humanity use the future quantum technologies in the best possible way. So I stop here and will then conclude after the panel. Thank you, Anousheh. Thanks.
So I have the great challenge of, in the next hour, walk you through how over the past year and a half we've come up from the breakthrough radar that GESDA has published, identifying quantum as an area of focus, and then driving it to a concrete solution. And to do that, I'm going to invite some of my colleagues to join on stage. So Matthias Troyer, who's the co-chair of the GESDA Quantum Task Force with me, and he's also the technical fellow and corporate vice president at Microsoft. Alberto Anfonsi. Alberto is Secretary General of Campania di San Paolo. And Tommaso Calarco, who is the chair of Quantum Community Network of the Quantum Flagship and head of Institute of Quantum Control Research Center, Jülich. And Urvashi Sinha, Professor Raman Research Institute, India, and a member of GESDA's Quantum Task Force. So we're going to have the panel in two parts. The first part is talking about quantum in general and why it's important, why it was part of the anticipatory science diplomacy agenda for GESDA, and why it's a priority for us to collectively work and discuss how quantum can play a role in our society. And then the second part will dive deeper into the specifics of the Open Quantum Institute. So with that, I'm going to start with my co-chair, Matthias. Matthias, what are some of the most pressing challenges facing quantum computing in achieving its promise and potential fully?
Okay, thank you, Anousheh, and thank you, GESDA, for the panel here and for the quantum work. This is a timely topic, important one for the planet. And I've worked in quantum now, I just checked it for more than 22 years. And looking back at that, I think we are at an inflection point here. When I look at where we were and when I look where we go and what we've done with the breakthrough radar, now this is the moment where hype gives way to clarity. Because we have clarity now on where quantum will go, we have clarity on the impact, and we have clarity on what it will take to get there. And the good news is quantum is real. Quantum is coming, the impact is real. And it will help us solve some of the most important challenges of the planet. But what are those? And it's basically simple. You don't need to be a quantum scientist for that, because what we know is that nature is quantum. And thus, to really understand nature, we need a quantum computer.
I like that.
So that's as simple as it is. If you really want to understand the chemical reaction, for example, this is a quantum process with quantum hardware. You can predict it accurately. So anything having to do with molecules, with chemicals, materials, drugs, pharma, nature in general, that's where quantum will help. That's where quantum can have that big impact. But now, sometimes people say, is that all? Then I say, look, when we look back at the history of mankind, we call the ages by materials, the Stone Age, the Bronze Age, the Iron Age, the Steel Age, the Silicon Age. So the materials really shape our progress. And now just imagine if quantum can help you really design new materials, new chemicals. If you can design ones with specific properties that can really change the future. Let's just use one example. I think we would all love to find a chemical that can bind carbon from the air in a chemical process efficiently. That's something, if we get that, that would be amazing, and that alone would be worth all, right? And how do we do it now? Yes, we search for those, but the way we do it now is we look at possible molecules, we make some guesses, but there's an infinite number of ways how you can combine atoms into molecules, and then one tries it out, thousands and tens of thousands of ways, and one tries it in an almost blind search. With a quantum computer, that can change. With a quantum computer, you can predictively and accurately understand how reactions work. And then that can guide the research, so you can really disrupt the way you do chemical research by being able to drive it in a way that you know what you want to design. And that's just one example, using the quantum computer to find a catalyst to capture your carbon from the air. Second example, it was mentioned here, fertilizer production. Now, that's something where we already have an efficient industrial process. The Baker-Bosch process, this is since more than a century. It exists, we have it, we can make fertilizer, and the process is energy efficient. We can't improve it. But it needs a big factory. And then we have to ship it from there. Now just imagine if we could find a new process of making fertilizer that a farmer can do on their own farm or in a village, if you can locally produce fertilizer. That can really change the food security, the food production. So there are many areas where quantum can have a huge impact just by inventing new chemicals, new materials. There's more. There's better batteries, better solar cells, better drugs, and more. So there are many application areas where quantum will have an impact. But what is needed to get there? What is needed to get there is we really need to build those quantum machines, and we have to develop those applications. And if I ask around here how many people understand quantum mechanics and can help us with that, it's few, and most people are scared of it. But so, and that's because this is one of the hardest challenges on the planet. It's one of the most impactful ones, but it's also one of the hardest. And we need the best talent of the planet. We need the best people. We need people from all continents with all backgrounds. It's not that we need the equity because it's a nice thing to have. We need the global talent because we need the best people on the planet for this. I say the planet needs quantum, but quantum needs the planet to realize. So to reap the benefits, we need to make sure that we have the best people globally working together. And that means we need education, we need upskilling. And for that, we need access to quantum technology globally. So those are the things we'll need to make that promise real.
Thank you for that. So we're entering the quantum era now for humanity. I like that. Tommaso, you chair QCN, representing a group of academic research and science in Europe. And I wanted to ask you, what are your thoughts? Do you agree with Matthias? Do you have other areas that you want to discuss?
Well, I've been asked here to also speak on behalf of our Quantum Industry Consortium, QUIC, which also endorses and supports very much. I co-founded this last year, so really it's intertwining academia and industry. And this intertwining and collaboration dimension is really the important thing which I'd like to underscore there in this whole initiative. There is a little distinction because, well, Matthias said, or maybe the question is, can quantum technology revolutionize the world? And a scientific answer to that is yes, we know. And there is another question, which is, will quantum technology revolutionize the world? And the scientific answer is, we don't know. Because to do these things which Matthias said, which are theoretically possible, you need to overcome such enormous challenges that we do not know whether it is feasible. And this is extremely important to sort of draw a line between hype and reality. Now, of course, I'm here, I'm Quantum. Yesterday I did a big event in the European Parliament, picture with the European Commission Vice President, so I'm supposed to tell you that it is fantastic, it is cool, it is super, it will solve all your problems. I don't think that I would do a good service to my field and to science if I would say that beyond what is scientifically sound, and what is sound is nobody knows how to solve the whole challenges. And this nobody means specifically that there is not any single country, not any single organization, industry, no matter how many billions they pour in there, because it is much more than billions, okay, that can do it alone. And this is really the wrong moment to say this on this earth, because we have, a war, which, is it a world war or not? We are not sure, but it seems that kind of, concepts like enemy, are becoming fashionable again. So it's really the wrong moment, even in Brussels, to tell, we want global collaboration. And still, it's the fact of the matter that without all the forces, all the intelligence, or the competence that we can master, it's unlikely that we will get it. And the risk is what Fabiola Gianotti said in the beginning. I mean, this is when they ask me what is the risk in some interviews, and they expect, like, nanotechnology, or you have, this power thing in your sunscreen, and it is bad for you, and so on and so forth. It's not like there are such risks for quantum. The really big risk is the one that you said, that this will be used to increase the divide between the rich and the poor, which is the real thing that we mean when we say developing. Mm-hmm. And it is necessary, it is indispensable to distribute tasks so that we manage to do what nobody knows, I repeat, that we for sure will be able to do. Nobody knows it. If they tell you today, they are lying. And also distributing not only tasks, but also benefits for the same reason, because in the end, even in a fully egoistic view, if I think next 5 years, or maybe next 20 years, maybe, it's fine to continue carbonize the world and, create more divide and so on. But if I egoistically think on a longer time scale, kind of like couple 100 years, it is really idiotic to go on, really just with some people taking advantage of technology. That's why we cannot go on. We have to stop, Even those of us who think that this is not ethically, acceptable, and those of us who do not care about ethics, but just about their own interest, it is not in anyone's interest, keeping this. And so, I mean, from the point of view of science and industry, where we see this need of working together to collaborate and to really support access, really we create the contribution of my organization, Jülich, will be to put our infrastructure for access for quantum computing at the disposal of the Open Quantum Institute. From all these points of view, it clearly converges that if we want to make it real, because it is not yet fully real, we can only do that together, and providing openness. And so this is why, this is what we stand for here. This is what I can only confirm from the point of view of academia and industry. Thank you.
Thank you, Tommaso. I have to say that we're grateful because it is because of the support of organizations like yours, we're encouraged to see how many have stepped up and have agreed to share their knowledge, their resources with the world to make sure that it is more inclusive than what we've seen in the past. So we're grateful for your participation. Alberto, as someone who's the Secretary General of one of the largest philanthropic organizations in Europe, what do you think is the role of philanthropy in making sure that there's this shared benefit for humanity?
Yeah, well, I can add something, of course, not on the scientific side, but I can speak to policymakers and politicians and diplomats and saying that what they already said, the fact that this is a huge opportunity, but also a huge risk of creating or enhancing inequalities around the world. I think that we can mention a historic that we all know, the Manhattan Projects during the Second World War, when the scientific community got to the bomb and changed the world after that. And all the last 50, 70 years now have been developed according to that moment in foreign policy, in diplomacy, but also in, how to say, where the money went. For example, in the common undertaking at CERN. And I think that we are in such position now, I mean, with this possibility to push the research and the application, the algorithms beyond what we are now experiencing, and proof of concept, say, what they already mentioned. But we needed to do it in an equitable way. And I think that in this sense, we have a role as a philanthropic world to make sure that this is done for all. And that's why, as Compagnia di San Paolo, we decided to be a first mover, basically, and to join the proposal of GESDA and XPRIZE and put some seed money. It's not a huge amount of money, but it's seed money in the prize and then maybe in the institute to foster all of this.
Thank you. Alberto, perhaps I mentioned here a little bit about the prize. So we are working closely with you all and GESDA and OQI to create a competition to bring the world's greatest talent to see how they can apply quantum computing power provided through OQI to solve some of the SDGs. And we're in the process of deciding which one of some of the examples that Matthias, for example, discussed would be ideal and the best ones to focus quantum computing solutions toward. So we've talked about the Quantum Task Force a little bit. And as the co-chair of the task force, we have the great fortune of being able to bring some of the best minds in and multidisciplinary areas of diplomacy, academia, industry together to look at how we can be mutual stakeholders and create solutions that will help achieve some of the goals that you all mentioned in inclusivity and creating a way to give access to the world in this, to this very powerful future technology that will be transformative for the world. Urbasi, you've been one of our task force members, so I wanted you to share with us what made you decide to join the task force. We make you wake up very early or stay up very late to join us through Zoom. And perhaps also share what do you feel are some of the guiding lights that has really moved our work forward and focused us on where we are today.
So thanks for the question. I mean, yeah, it has been an incredible journey, actually. For the last 18 months, I've been in this force from the very beginning. And as you rightly say, we have all been meeting at different time zones. But what actually motivates one to join something like this is, of course, the bigger aim that this OQI is going to have. And so it has been a very enlightening experience, I would say, to participate in things beyond our usual quantum work, that we do in the lab. The aim is very unique and very challenging, I would say. It all sounded very nice when all of us, spoke about everything one can do, but I don't think it's particularly straightforward to kind of achieve that. And the first few discussions, I just wanted to walk through, how the task force evolved and what we have been doing really for the last 18 months. So the first few discussions, I think, actually set the stage for what we will do and what we won't do. There was a lot of discussion in the beginning as to what is the scope and so on. And so what we decided early on was that what we won't do is like work on the hardware or, actually work on something, creating something at the OQI. But it is more about facilitating, research in a collaborative way, which is, sort of open, equitable, and useful for humanity. So that was the idea. So we very early on decided that, it will be an enabler rather than somebody, a group of scientists just working on something, which is something we have all over the world, right? So this was one of the first things. And one of the USPs I felt of this task force was this being inclusive. This is a word that I have heard being used a lot in various fora. But then in this case, it actually started off on that note from the beginning. So there were 7 or 8 people in the beginning in the task force, and they were actually from these 7 or 8 countries all over the world. So, it wasn't a US-based or biased thing, or, China. So we had US, we had China, we had Canada, we had, South Africa, we had, and of course, I am from India. So we already got that right from the very beginning. And I think that was a very good thing to go forward with, right? But then, the thing was about making quantum information available for all. And when people asked me in the beginning, what is this thing that you're trying to help with? And I said, this is about making quantum available for all. And it seemed a little bit like wishful thinking, even when we started, and to people around me, that is this really going to happen and so on. But then the whole idea was to discourage forming some kind of a niche quantum club where only the developed nations would, contribute. And so this thing about this divide, which we did not want. And so the focus was on trying to see how to make it happen. So it wasn't going to be wishful thinking. And 18 months have gone in turning some of it into less than wishful. I would say more than wishful thinking, right? So it's sort of becoming more and more concrete as we go along. And this research with societal benefits is something, I think, which will make this happen. So we are not going to come up with things which will just further our own selfish interests, but it'll be more aligned with the Sustainable Development Goals of the United Nations. And so I think that can unite and make this more than just, wishful thinking. So coming to your question about my association with the task force, so what I've personally enjoyed a lot is, our openness in discussions and willingness to adapt, right? So it's not like we've always agreed on everything. When we started these meetings at 10:30 p.m. IST and went on till 12 a.m., we didn't really agree with everything everyone said. And I think I really liked that, because there were so many people in the forum who represented different portfolios, but they listened to the other person speaking. And so one discussion, if you remember, Anusha, is about quantum computing and whether we should also go into quantum communications and quantum cryptography as one of our areas. And so this is something which came up. And of course, I have always been a bit too vocal for my own interests in life. So it was like, is this really something we should do? Because why should I give my security solution to another country? Even if we are doing open research, security solutions is something which perhaps is very personal and very country-specific. So we actually decided then early on that, we are going to perhaps focus for now on the computing-based solutions, which could probably align themselves better to the SDGs and maybe deal with these issues once this becomes a little more acceptable, let's say. Because, acceptability was one of the first things which we were not sure of, and so it has been a journey. And one thing I would like to add here is that it has not been always easy to understand and align with the task force. And I must thank Daria here for, these various task force meetings which she would organize and always start with a very positive and smiling introduction, regardless of what the situation was. And I think that set the ball rolling, really, for the rest of the 2 hours that we spent on deliberating. And we wholeheartedly participated in everything. And the formulation, we had these teams that we built up very early on, right? So there were teams for research and development, for education, for business model, for diplomacy model, as well as for the SDGs. So, very early on, we kind of divided the work a little bit, and then these teams really were committed to the cause of what they were trying to sort of come up with. And so, I personally contributed to the research and development one, but it was very nice to be kept abreast with all the activities. And I would say that, before all this, I was a quantum physicist. I was working on, I would say, some good ideas in the lab, but then now I feel that, it is a bit more than that in terms of trying to find some societal significance to what I do and what others do. And of course, I'm very privileged here that I'm representing the Raman Research Institute, which is one of the, the first institutes which is supporting the solution idea as one of its partners from the very inception. And as I was telling some of you earlier, our country, India, is poised on starting what is called the National Mission on Quantum Technology and Applications. And so it's, again, aligned with the European flagship and all these other large funding, initiatives that different countries are doing. And having this experience of working hand in hand with several brilliant minds, I would say, in the task force, I'm hoping that, I can, because I have also been very closely involved in this national mission inception and build-up, I can perhaps help in aligning some of the work there towards open, quantum research, right, for this next 5, 10, 25 years, as we say. And so, yeah, it's been a fantastic and very stimulating experience being a member of the task force.
Well, thank you, Basi. It's been a privilege to have you and all the rest of the members of task force showing up and really bringing their best ideas and best versions of themselves in a very collaborative manner to the conversation. And we're blessed to have Daria as the sort of our cheerleader to help us get through the difficult conversations to the real good part of this. So it's been wonderful to see it go from just the concept and idea to what it is today. And with GESDA's support, it will go even further. So we're grateful for that. With that, I want to thank you all for sharing your comments and ideas today. We're going to share a video that will describe the Open Quantum Institute in further detail. And then we will be joined by a few other panelists to help us describe the mission and the direction of OQI further. Thank you again.
What do we mean when we talk about quantum?
The big news about quantum is that in the first time in millennia, we invent a new way of computing.
Quantum technology is something that's rapidly developing, and it will have a big impact on the world.
Our work's very necessary if you're going to use quantum computing to actually work on real-life problems.
To be able to actually share what the quantum capability will allow in the future, we absolutely need to open it up.
There will be problems we can solve with quantum that will be totally intractable classically.
In 2050, 3/4 of the world's population will live in urban centres. So we're already trying to anticipate what's happening in the world, as we know, and how there'll be a need to adapt the way we live.
At this time, quantum computers will no longer be isolated to the lab. Governments, private companies, institutions of learning will all be harnessing this technology. We see this already having a huge impact on aeronautics and much more.
We'd very much appreciate if governments and particularly local authorities would look objectively to the future, to spare some time to look at innovation.
It is a geopolitical topic where many public and private actors are already investing.
There's a huge gap between people who know the theory of quantum computing and people with the application problem. And we started to bridge that.
Looking at quantum computing through a diplomatic lens, we see that there are gaps. Some players cannot afford to take part in the development or use of quantum computers. Also, the application in wider societal and environmental challenges has not been fully explored. We believe everyone should have the right to benefit from this science, and its potential should be harnessed to progress the UN Sustainable Development Goals.
One of the core ideas that came from the task force was an Open Quantum Institute, an inclusive, collaborative effort around developing the technology will ensure that the future of these technologies will benefit the entire human race and not just certain companies or countries.
With an Open Quantum Institute, or OQI, GESDA and its community propose to enable a space where quantum computing is made accessible and understandable to all.
Bringing these actors together to make a baseline for use cases around SDGs is going to be at the core of what the Open Quantum Institute will bring.
This is fundamental to our work, bringing science and diplomacy together to allow room for discourse and multilateral coordination. Brokering this conversation in the early stages of any new technology will allow everyone to have the tools that impact people, society, and the planet.
The Open Quantum Institute is well placed in Geneva and in Switzerland with different actors from the international governance world.
The Open Quantum Institute will work with the global networks of partners who focus on universal challenges and the UN Sustainable Development Goals, who help define and prepare real-world use cases for quantum computing applications.
Quantum is a complex technology. It's something that when you just say quantum, a lot of people run away because I'm not a physicist, I don't know anything about quantum.
We need the best and brightest people on the planet to help us.
We are calling to technology providers and developers to express their interest in tackling the SDG use cases the OQI will be providing. We also need governments to actively help shape the multilateral relevance of the Open Quantum Institute. We want the OQI not to just be an idea on paper, but a real center where you can all come and benefit from it. This is a brand new approach, and we want you to join the discourse and share your ideas and help us test it. Together, we can use the future to build the present.
Thank you. Thank you. I would like to have our next panel join us. Thank you. So, as you heard on the video, at the core of OQI is a focus on using this powerful technology that you heard from our previous panelists and make sure that this power is used in collaboration towards solving problems that benefit humanity, toward problems like the ones that SDGs have identified for us. And we believe that it can be achieved. Of course, it's not an easy task and it requires a lot of resources to come together. But we also need to, as you heard from Tommaso, we need to separate the hype from reality and identify where we can actually use this powerful technology. So with that, we have been GESDA has been organizing several workshops to first identify what are some of those problems that we feel quantum can play a major role in solving. And Graham, you have been, as the director of the Geneva Center for UN Habitat, you've been participating in some of these workshops and discussing some of the areas. So would you share with us some of your experience at these workshops, what solutions, what ideas have been discussed, and perhaps tell us what's your favorite one?
Thank you very much indeed, Anusha. I mean, for me, the SDGs...
Hold on, so. Is there a mic? Thank you.
For me, I mean, I've been working for the UN for the past 30 years now. The SDGs were preceded by the MDGs, but really this was the first time that we actually had a clear set of goals. Now, the SDGs are now, we're halfway through, we're almost halfway through, and, you know, the devil is actually in the detail, because as we drill down to look at the SDGs,
what that means and how they are applied, of course, has been quite difficult. But I'm going to share with you a couple of examples. We heard already from Matthias about the Haber-Bosch process. I'm originally a chemical engineer, so of course these things I get really excited. I'm a UN diplomat, but I've got a chemical engineer in me burning to jump out. But basically, that's a process that 100 years old, lots of pressure, lots of temperature to produce something very simple, a simple chemical reaction of ammonia. But the idea that nature does that much more effectively, fixes nitrogen, is a complex system of biological and biochemical and enzymic processes that do that. And we still haven't completely worked out how that process is. If we did, we'd have very cheap fertilizer already. So there's an opportunity both to look and use quantum computing to address that complex set of equations. But then also, if you're going to do that process, you need to find a way of capturing the biological system in a reactor so that you can intensify the process. This is what chemical engineers do all the time. So the idea is that we need the quantum computers not only to understand the processes, but also how to design the reactor and the matrix and how using, surface chemistry and other things, along with the kinetics, to get the best area of the best result. The other area which we've been also discussing as a good idea is the issue of antimicrobial resistance. Now, like with the Haber-Bosch process, the way we treat wastewater hasn't changed in 100 years. Activated sludge was invented in 1928 in Manchester, and we still basically use it. And nobody's interested in really innovating in wastewater because it's not a sexy topic. But now that antibiotic residues are present in wastewater, and there's a threat to our health because we could die from very simple diseases because the antibiotics become resistant, people have suddenly become interested in wastewater. They became interested in wastewater also because it can be used to track COVID, wastewater-based epidemiology. There's a whole range. So wastewater, this is a complex sort of toxic cocktail of different things. We can easily remove the things that take oxygen out of water. But what about those antibiotic residues? Yes, there's processes to remove those, but they're very expensive or they're not at scale. But really, we could, if we think carefully, use quantum computers to design systems, again, nature-based solutions, which can remove those antibiotic residues from wastewater very effectively. In the same way a drug can latch onto receptors in the brain, we can produce a material that will not filter out, but will remove those substances. But again, you need to understand those processes, and you also need to understand how you design your reactor that will do that. So that's one part of the equation. The other thing is, and this is perhaps where I take my chemical engineer's hat off and put my development hat on, that, whilst we're developing this technology and using quantum, we also have to understand how we're going to deliver that mechanism on the ground. And I mean, we know from the way the world is changing, I mentioned about it becoming more urban, but how we reach out to those communities, how we use local expertise, local governance structures to make sure these systems can be equitably applied is, of course, also very important. So we've got to develop two at the same time. But it's actually such a fascinating example, and we're really happy from my side as a UN bureaucrat, but with a chemical engineer somewhere inside me originally, to help support the GESDA initiative.
So do you have a favorite one? Which one do you feel like would be the most
I don't
exciting?
know. There's another one as well, which I'm also interested in biological hydrogen production. I still feel that that's something that we need to think about. Let's not get fixated on electric cars with batteries. Hydrogen, nature produces hydrogen very effectively, but it's another biological system which we can use quantum computing. So yeah, I don't know, it's a difficult one. They're all equally important.
Thank you. We'll probably try to do all of them, and hopefully we'll get people who want to work on all these issues around the world. So, of course, one thing I've learned, and at the XPRIZE we say that all the time, the greatest challenges, and we've seen this throughout history, they're also the greatest opportunities out there. And I feel like with OQI and our mission, one of our greatest opportunity is to be a center for this type of focus, to bring attention to these types of problems, be a center of expertise for SDG type problems where quantum can play a major role. While OQI will not do its own R&D and will not perform our own R&D, we have amazing research institutions that have already partnered with us, and we hope to grow that list. And by identifying these areas of interest for research, we hope that these partner institutions will actually take on the task of performing that research and sharing the results with the world to benefit the world. And in the same manner, we want to then bring the talent in the world, educate them, get them interested, and involve them in creating these solutions. So by providing a pool of quantum computing resources to everyone around the globe, we hope to create an equal and level playing field for everyone to participate in creating these solutions. And we've already blessed that we have a few companies who've showed interest to provide quantum computing resources to us, and we hope to grow this list of industry players from large companies to small companies to grow that list. But I feel that this type of collaboration is very important, and as someone who's been blessed to be able to see this firsthand in space, and when I was on the space station, seeing how research is being performed on this really interesting project that started with 16 countries collaborating to create an orbiting, basically research center, where countries who by themselves may not be able to afford to have a space-based research center were able to participate and run research that would benefit not only their own country but humanity. So I think we have great models out there like ISS, like CERN, where collaborative research can be done successfully, and we hope that to apply this type of experiences to the way OQI will operate in the future. And we're in the very exploratory stage of this program right now. And as you've heard, even here, we have debates over where we need to focus our energy and resources, which problems are the ones that are top priority. And we'll continue these debates in the future and try to organize them in a fashion that will be mostly beneficial to everyone. But in order to do that, of course, we need to scale up. And while we scale up, to make sure that we have great partner and level the playing field. These are some of the partners who have already expressed their interest and have signed up to be partnered with us. So as you can see, we went from this being like just a dream to something very real with the names that you see on this page. And we hope to grow this every year and share some of the exciting news about more partners joining us. But using examples as a way for us to move forward, Professor Ode, I know you've organized a program in 2022. You're a professor at NYU, and you have chaired the Abu Dhabi International Hackathon for the Social Good. So I would love for you to share some of your experience and what you found in that exploration of this type of capacity building and how it may apply to OQI.
First, I would like to thank GESDA for inviting me here today, and also congratulate you on this wonderful summit, bringing all these amazing people together, the scientists, the diplomats, and also the goals and the plan to action. I mean, the action is key. I think we all really need it, and we really need to step up to basically bring better solutions and to save basically the planet. So I really have a lot of hope in what you have begun to work on, and I wish you luck for the future. So basically, I'm an NYU professor in computer science, and 12 years ago, we opened a university in Abu Dhabi. So I went to set up the computer science department there, and I wanted to make sure that my students also are connected to the innovations that happened in the world, and I felt like it was a bit isolated, so I wanted to bring the world to them. But also I noticed that a lot of the events in computer science are either happening in the Europe and the US. And so it was a chance for me to basically use Abu Dhabi because it's also close to the global south. In a way, it's connected to a lot of places. And to try to do computer innovative programs, international program in a way. And so I started the NYU Abu Dhabi Hackathon for Social Good. It was the first hackathon actually in the Arab region. And what I did, the idea is to really, again, bring it, build an international connectivity and have the center be outside of Europe and the US, but bring the topest talent. So I made sure that the students that we get really the top talent. So the students who were nominated by their top, by the professors from top universities. And I was fortunate to have funds, so I can be selective. So I ended up with about 200 students, really top students from all over the world. They're coming from top universities. They're also coming really intelligent students with very strong science background from all over the world. And I was amazed I made sure also that that the teams are diversified. So we didn't want, for example, the Harvard and the MIT and Yale students working together. So we made sure that there is country, gender, and so on and so forth, balanced teams. And I made sure that through this process, I mean, it's a hackathon, it's 4 days, but we did also virtual online education to make it balanced for everybody, to make sure that the technology and also, AI and machine learning, the principles of computer science are also infused in the program. And I made sure also to bring excellent mentors, like computer scientists and also developers, to make sure like the top, basically engineering aspect of building application is there, and also the social good, because I wanted it to be down up rather than, so I wanted people coming, especially it was when we arrived to Abu Dhabi, it was the beginning of the Arab Spring, so there were a lot of issues that people, especially the young people, were tackling and wanted solutions for. So the ideas, in the beginning I thought, there are not going to be many ideas, and we're afraid, and I would always contact the UN and other organizations to bring ideas, but then, there would be like hundreds of ideas on the board coming from these communities, whether it's Tunisia or Algeria or Palestine or Libya and so on and so forth. So it was, we've learned so much from this process, as from pedagogy to also the strength of, like we talk about sometimes, people from the developing world not having, for example, the right skills. But actually, when you have the brightest students, they also have strong science skills. They're coming with really strong science skills. So you can really build on that. So last year, I decided to focus on quantum computing, because as we know, and it's very important, which is what we've been talking about, which is the gap that we are, it's really important, because it's not just that we're seeing the gap, between the developing world and the developed world, but it's also within, even in the US, you have basically, the top universities in the world, but you have also the poorest university in the world in a way. So it's very important to keep that in mind. And even I come from NYU, we haven't really had, for example, courses on quantum computing. We do have a center, but it's in, more towards physics. So this is really important to keep in mind. So this is the time for us to really start to talk about education, the right education for quantum computing, but also bridging the gap between theory and practice in terms of application of quantum computing, not just the focus on the theory, but how do we use that? And I know Calgary's already have a master program that trying to do that, and I think that's the right approach, and that's what I'm trying to do with this hackathon, is to bring all these young people, the smart people from all over the world, work together, not just separate. And actually, one of the beautiful things to see at the end of the hackathon, when they develop their application, first of all, they learn how to use the hardware and software of quantum computing, they also learn the principles. They learn also specialized topics. For example, if they want to work on algorithm on AI or on anything to do with chemistry or health, they can tackle any topic. And they produce great application, and they learn so much. And in the beginning, a lot of them did not know anything about quantum computing, and I was really scared that we're not going to be able to build application, because I'm keen after the third day that we build applications, and they have to demo a working application, and we have really hardcore judges, and they do succeed. It was beautiful that all the team succeeded by the end. And with all the different level of experiences, like I said, I bring the Oxford, the MIT, the different levels, they work together, and there were no complaints, and everybody benefits from each other, and they learn from each other different types of skills, and then they really grow as a team. And I've already seen people that were able to do startup together. The people have gotten PhDs because of the work that they actually started to work on. They took this work, they actually it became like their thesis, their master's thesis, or something they work on and continue to work on for their PhD. The collaboration across boundaries is really real and productive and beautiful, and it also brings solutions that people are passionate to problems that they're passionate about solving, especially in their communities. It really opens their eyes to what computer science can do, what the potential of quantum computing. I mean, some of these people have never sometimes left their community, their country, have never met a Googler or a Microsoft person or a professor, and now they walk away with a network of 200 people. This is a small initiative. It's a small, but I can see how it amplifies. I mean, at NYU, when I do a lot of work, sometimes it's really hard to see the impact. But you go to these places and you see, like, somebody that's coming from Libya or from Jordan, and they walk away, and now they can compete with this project with somebody that, is graduating from MIT, because they've learned some of these very unique skills. And you're also bridging the gaps, and you're providing these skills that are going to be very key in the future. And I think that inclusion is so important and bridging the gap, because there is no country that's going to be able to solve the problem that we're going to save by itself. The collaboration and finding all these brilliant people around the world. And also, everybody has a priority in terms of what is the main problem that we want to work on. But when you talk to somebody from a different country, they have a different approach to how to solve it. They have a different priority, and we need to include all of these different approaches and priorities and problems, and make it also a priority for us. Like, we need to, we don't own the solution in a way. And together, all of us, we will do that. And I think there is a belief that we know that, but we have to get there. And we can get there by starting with the education. The education is really key. Whether the debate is if quantum computing is going to be the answer or not, we need to start. We cannot afford to wait. It's really coming here faster than others. And we need to empower our students. We need to build these educational programs. And we need to make sure that it's access and these kind of skills are available, and the access to these machines available to everybody. And we can't wait. We have to do it as soon as possible. We're already late, actually.
Thank you so much, Sana. I think I can concur with you what I've seen through XPRIZE's work with our competitions. Most of the participants are students from around the globe, and the excitement and the collaboration. Sometimes the teams actually don't even live in the same country, and they're collaborating across geographic boundaries. And one thing about developing countries, they're mostly also very young countries. And the hopefulness and enthusiasm that the young people have, if we're just providing them the opportunity and the access to technology, access to education, as Matthias said, which is very important, I think we can build a very bright future for humanity. So thank you for sharing your experiences. I think we can definitely use that for OQI. We've heard from Urbasi how important was for us to pick an area where we can find common ground. I think the work we're doing in quantum requires developing a level of trust, so it's good to pick some areas where we can really start working together and build that trust factor and move it forward. And that's where diplomacy and engaging on that front becomes very important. And I know that, Matthias, you are sort of representing the expertise side, the scientific side on our task force, but I think diplomacy is a very important part of our work in the task force. So I wanted to, maybe you can share some of your thoughts and ideas of why this is so important to you.
Yes, so we've talked a lot now about all of the good impact of quantum, about all the amazing things we can do with this disruptive technology. But with every new technology, there's also real impact that we have to guard against. And quantum is no exception here. But when you hear about it, then you also have to keep in mind that we live in the world where the media are motivated to scare you with sensational headlines. And so a lot of what you read in quantum is about the dangers of quantum and the hype around quantum to get more clicks on the web page. And too little still is about facts. So it's really great that I have the time now to share some facts with you and create some clarity here. And so the threat of quantum is to public key cryptography. That is what you use when you go to a web page that's encrypted, when you upload credit card numbers, when you go shopping, when you send an email. And the way that is encrypted without pre-sharing a secret is that one uses a hard computational problem to encrypt it. In this case, the most common scheme depends on the fact that it is easy to multiply two numbers, but it's hard to find the prime factors. Let's say 3 times 7 is 21. Okay, 21 we know is easy, that's 3 times 7. But if you take two 1,000-digit numbers, it's again very easy to multiply them. But when you have this 2,000-digit product, it's extremely hard to find out the prime factors that you multiplied. And that's the basis for much of our public key cryptography. The way it works is that when you know the product, you can encrypt it. So I can share the product of my two big numbers with anybody, and then you can use that to encrypt your message. And only the people who have the two prime numbers that you multiplied can decrypt it. So because I have them, I took two prime numbers, I multiplied them, I gave you the product. Based on the product, you can encrypt it, but only if I have my two prime factors can I decrypt it. Why is it safe? Because taking this 2,000-digit number and looking for the prime factor will take 100 million years on the biggest computer we have, the biggest classical computer. When we have a quantum computer with a few million quantum bits, then it will be easy to break this. So the quantum computer that way breaks our most common public key cryptography. And so there's a threat. All your e-banking, your medical data that you upload somewhere, that can all be exposed now. So there's a threat here. And how do we counter that? So the first thing is when we at Microsoft design the future quantum computers, we design them from the ground up with built-in access control. We want to make sure that if you run a chemistry application, you want to design a catalyst for making fertilizer, a filter for capturing antibiotics or something, that those calculations run. But when a bad actor comes who wants to use the quantum computer with a program to break crypto, then we can detect that and we can block it. And you can build that directly into the hardware of the machine that we can control the access to only certain types of application. So that way we can build machines that you can use for good and that you can share globally that prevent the bad use. That's one step, but that does not really protect you because somebody else may build a machine that can break it. So the good news there, though, is that the reason why we chose the crypto schemes that we had that was based on the fact that finding the prime factors is hard. That's a hard computational mathematical problem. We know since 20 years that quantum computers can break that, and so scientists have worked for 20 years on new crypto systems. And we call them post-quantum crypto, so that's the crypto system we want to use after we have quantum machines. or we call the quantum-resistant cryptography. So these are based on math problems that are also extremely hard classically, but that are also hard quantumly. So those are problems where, again, you can go one way and share a key that people can use to encrypt, but to decrypt it, to break it, if you don't have your private key, you need to solve a math problem that will take 100 million years on a classical computer. It will also take 100 million years on a quantum computer. And so those are the new crypto systems that we can move to. Thus, by replacing the current crypto in coming years by these new crypto systems, we will then be in a world where there's no quantum threat to crypto. So we can mitigate it. However, there is an even bigger risk. And the even bigger risk is that because of that threat to cryptography, there are efforts by certain actors, certain nations to think about export control on quantum technology. Let's restrict it to just people in the EU, in the US, in Australia or somewhere. And the effect of export control does not really prevent bad actors from getting access to it. It's just the bad actors within a country. It doesn't solve the problem. But the threat it poses is it prevents us from working together to actually building the machine. So this is something, so that is the real threat. That because of the fear of quantum endangering cryptography, we will impose restrictions that will prevent us from building the machines, that will prevent the good use while not being effective to prevent the threat. And because we have ways to mitigate the threat, we should actually do different things. So what we should do is we should work on the good use of quantum. We should work together to make it happen. And then we have to jointly mitigate the threats. And what we need there is for the government leaders and the diplomats, we need your help to embrace really the global access to quantum technology, because we need that to make it happen. Because as we heard from Tommaso, we don't yet know how. It's a super hard problem, so we need the global talent to make it happen. But at the same time, we also need to globally embrace the post-quantum crypto standards, the new crypto that will keep us safe. Then secondly, we need all of the IT leaders, the big IT companies, and all companies using IT start to embrace post-quantum crypto. We have to upgrade our infrastructure to make it quantum resistant. And that will take time, so that's something we should start now. We know how, we know the new crypto systems that are safe. The National Institute of Standards and Technology, NIST, in the US has chosen then you have the candidates that will be standardized in the coming years, and then that has to be deployed quickly and as soon as possible. And then we'll all be safe against quantum attacks to crypto. And then thirdly, we need all of the researchers, the scientists, the technology providers to work together to enable the good use and mitigate the threats jointly. So that's what we have to do, and that's why we need both the scientists and the diplomats, and I'm optimistic that we can do it, because the impact the quantum can have is huge. It's important for the planet. And that should motivate us to make it happen, and we'll find the solutions to keep us safe while doing that.
Thank you, Matthias. Very important call to action here from Matthias. But as you've said, the cat is out of the bag, and I think advancement quantum will happen, so it's important for us to get ahead of it. And we're very fortunate, so one of the reasons we felt OQI in Geneva makes sense is because it is a hub for diplomacy as well, and we have been fortunate to be able to have many of the ambassadors involved in our conversations and providing their support and interest in supporting this work. So there are a few here in the room that if you feel comfortable, I would love for you to share some words and why this is important and why you support it.
Well, thank you so much, Mrs. Ansari. I am the Moroccan permanent representative here in Geneva. Indeed, I have been associated to some talks on the issues we are discussing this afternoon since a while. For that, I thank very deeply the Swiss diplomacy, which is taking the leadership on this process of mixing science and diplomacy to prepare a better future for all of us. Since yesterday, we are hearing many times and several times the word of inclusivity. I am here to testify that there is effectively a strong will, to make it very inclusive, and it has been demonstrated to us right now. What important is to make everybody on board when it comes to these issues. It's about peace, it's about development. You spoke about SDGs, and Morocco is highly interested because, as maybe some among us know here this afternoon, Morocco is at the forefront, for example, for food security worldwide, when it comes to fertilizer, for example. So thank you so much. I won't say more, just to indicate that my foreign minister of Morocco, will contribute tomorrow to the high-level dialogue, and he will frame, most certainly better than me, the perspective of Morocco when it comes to this important process, and particularly, of course, the launchment of the Open Institute, and hopefully be all together again, hand in hand working. Of course, there are some graduation in the technology, control, development, etc. But the more we open the doors and the windows, the better will be for all of us. I thank you so much.
Thank you, Ambassador Znibir. Anyone else would like to share a few words? Sure. Ambassador Beckers. We have also someone in the back.
Somebody else first? All right. Well, according to good protocol, I can just say I fully concur with my ambassador, the ambassador from Morocco, with the words you mentioned. But let me add maybe one or two reflections. And one is a personal observation, if I may. As the Chinese say, we live in interesting times, and I personally believe that from the following perspective. There was a time when science and, spirituality or esoterics were a world apart. That has changed. We now see that science and what we call spirituality come closer, much closer. And quantum physics is a very important player in that. Let me give an example, telepathy. What is it, 20, 30 years ago, the scientific community said, can't be, that doesn't exist. Now, it's acknowledged, it's appreciated, it's even used. And we can't explain it, but we acknowledge that it's there. So I think we're living in very, very interesting times. Now, that's maybe a new paradigm. And I think GESDA is part of that new paradigm. I'm looking at my notes because I took some notes yesterday when I was here. Yeah, it was said that science and technology move faster than ever before, which is actually true. Well, we, the diplomatic world, the rest of the world, cannot stay behind. We need to be involved. And that's where the initiative of GESDA comes in. You bring science and diplomacy together. And it's so important. Let's face it, ambassadors or diplomats are not the most science savvy. There are some exceptions, Mr. Alabaster. But we need some encouragement, and that's exactly what you're doing. So I'm very, that's why Ambassador of Morocco and many others, including myself, are such big fans of GESDA. And when it comes to quantum, I'm very happy to also mention or announce that I think it's the Quantum Delta NL will be part of the Open Quantum Institute. Cooperation is key. That goes for nations, but it also goes for academia and the industry. We all need to work together, and that's why I think this initiative is just wonderful. Another quote from you, if I may, Matthias Streuer. With quantum, well, I do this without my glasses. With quantum, we solve some of the most pressing issues of the world. I mean, how wonderful it is to be part of that. So, thank you very much.
Thank you, Ambassador Beckers. Thank you. Of course, we have also other partners in the room who have been instrumental in making sure we have advanced in our mission. And I want to thank all of them from the academia again, from the industry, and from the diplomatic corps. I like to see if there are any of the partners who would like to make a few words in their support of OQI.
Yeah.
Over here.
I can start, maybe I'll give you the microphone. So I speak here on the behalf of the newly created Center for Quantum Science and Engineering at École Polytechnique Fédérale de Lausanne, which is part of the ETH domain here in Switzerland. A bit of context: for at least the last 12 years, EPFL has been having a leading role in research, education, and innovation in the field of quantum computing, including quantum algorithm and enabling tech and quantum simulation, quantum sensing. And one example is we have recently launched a new master program to educate a new quantum-aware, quantum-enabled workforce citizens. The EPFL Quantum Science and Engineering Center vision of inclusiveness and open science is perfectly aligned with the stated mission of the Open Quantum Institute. And I would like to keenly add that we are only one among several centers here in Switzerland and also worldwide who have pledged to support the Open Quantum Institute. Just more concretely, we're interested in opportunities to contribute to educational programs that would be open to globally, and also to provide some help in evaluation use cases that align with the Sustainable Development Goals. Thank you very much.
Thank you. Anyone else? Thank you.
Hello. First of all, I would like to applaud our chairs for their 18 months of effort in making this program come together. They deserve much credit. My name is Worley. I'm the CEO of StrangeWorks, which is one of the industrial partners. And we started our company with the vision of humanizing quantum computing for the world. And I will simply say that I believe 2023 will be 1963. In 1959, Jack Kilby invents the integrated circuit. Before that, you bought transistors individually, one at a time, and it started the computer revolution that has led us to where we are today. I believe that 2023 is the starting gun for this, and I believe that if this is correct, it should be fair and equitable and inclusive, not just between men and women and different cultures, but between countries cooperating together for the betterment of humanity. Thank you.
Thank you very much. Great. So with that, I would like to invite Fabiola back on stage to tell us what's next. What are the next steps we're going to take? Thank you, Fabiola.
Thank you very much. Since we have negative time left, but negative time exists in physics, so nothing to be worried about. So I would first like to thank the panelists, this panelist, the previous panelist, and for the very insightful discussion. We learn about opportunities, we learn about challenges. I think one of the things that I retain, and many of you mentioned, is actually education and training. We need to prepare today's and tomorrow's workforce that will work on quantum and use quantum at the best. We also heard about realism. We have to be realistic. Quantum computer is not yet there, and I think we have to be realistic. However, the word impossible does not exist in the scientist dictionary, so this will come at some point. I'm quite positive about that. Then I would like to thank also the chair of the task force, Anousheh and Matthias, for the work, and all the members of the task force for the hard work over 18 months. It was a science and diplomacy task force, and they came with this beautiful suggestion of an open quantum institute, which was enthusiastically supported by the board, the GESDA board of directors. So, and now comes the implementation. So what's next? The first step involves all of you and all the people that are linked to GESDA, so the worldwide community linked to GESDA, because we are going to launch a survey to get your thoughts, your suggestions, and this will be extremely important, so please try to answer and to contribute, because the Open Quantum Institute will be successful if everybody contributes to it. Second, we are going in 2023 to launch an incubator. The incubator will be a prototype of the Open Quantum Institute. You know that scientists like to work first with prototypes and then, try and then modify, improve, and then before we launch the full thing. I think it's a prudent approach. And during the incubator, well, there will be several things that will be done. First one will be to develop a governance for the Open Quantum Institute, to develop a funding model, and also to start collecting use cases for interesting problems related to the SDG to be solved. We learned about wastewater, the virtue of wastewater. It was very good. But there are many, many others that will have to be solved. Then, of course, I have to mention the XPRIZE prize competition, jointly supported by GESDA and XPRIZE. Thank you very much, Anousheh, for this, which will allow also, again, the first use cases to be collected. And then we will continue to look for partners. There was an impressive list of partners from academia, from diplomacy, from industry, R&D, etc. That's been already lined up and raised and brought together. But we need to scale up, as Anousheh said. So I think I will conclude by saying what Matthias said. Matthias said we have to make it happen, referring to quantum computing. I say it now, referring to the Open Quantum Institute. We have to make it happen. And for this, we need all of you. Thank you.
Thank you very much. Thank you. Thank you. Thank you very much. I think we're at the end of our session. And again, appreciate all of your participation and hope to hear from you on our survey. Thank you. Have a great afternoon.
Thank you.